Technical objects are made from one or more materials, and when manufacturing we must consider factors such as constraints, deformations, properties, degradation, and protection. With regards to compression, this is a material subjected to forces that tend to crush it. Tension is a material subjected to forces that tend to stretch it. Torsion, a material subjected to forces that tend to twist it, while deflection is a material subjected to forces that tends to bend it. And finally, shearing is a material subjected to forces that tend to cut it. And these symbols are important to know. With regards to deformation, deformation could be elastic, leading to a temporary change, plastic, leading to a permanent change, and fracture, where the constraint is so intense that the material breaks. On to part 2. Considering mechanical properties: hardness, ability to resist indentation; elasticity, ability to return to the original shapes; resiliency, ability to resist shocks; ductility, ability to be stretched without breaking; malleability, ability to be flattened or bent without breaking; and finally, stiffness, ability to retain shapes when subjected to various constraints. Other properties to consider are resistance to corrosion, as well as electrical conductivity and thermal conductivity. Degradation of material is a decline in some of its properties due to the effects of the surrounding environment, such as rusting, while protection is the application of procedures that prevent or delay its degradation, such as rust proofing. So all these factors taken into account, we must look at the types of materials that we would use in order to manufacture an object. Wood is a material for obtained by harvesting and processing trees. 2 types of wood are hardwood and softwood. Varies with species, speed of growth, and water content. Properties to consider are hardness, elasticity, especially low thermal and electrical conductivity, and the ease to which it can be shaped and assembled, as well as colors and lightness. Wood could be modified, such as plywood, particle board, and fiberboard, but wood can degrade because it comes from a living organism. It's organic, such as fungi and microorganisms can infest wood and feed off it and cause it to rot. So therefore, wood can be treated by dipping it in an alkaline solution and heating it to a high temperature. The other material to consider are ceramics, which is a solid material obtained by heating inorganic matter. Properties: the key one to understand is that it has low electrical conductivity. It's very hard, highly resistant to corrosion, but it is very fragile. It's durable, but you must avoid exposure to acids. Metals and alloys extracted from mineral ore. They're shiny, malleable, ductile, and they're good electrical and thermal conductors. Alloys means they come from a combination of metals. They could be ferrous and non-ferrous. They could be protected, or they could be enhanced using steel heat treatments, such as quench hardening and tempering, in which the steel is heated to high temperatures, then cooled, then elevated again to rearrange the atoms, as well as annealing, which restores original properties of steel once it's been deformed, such as by welding. Other categories to consider are thermoplastics, which is soft enough to be heated to be molded. However, plastics can be degraded by the penetrations of the liquids, oxidations, and by ultraviolet rays. Finally, composites are composed of a matrix, which constitutes the skeleton of material, giving it its shapes. It can be reinforced to strengthen it. Properties is that it's very resilient, and composites are both stiff and resilient. Examples of composites are in aeronautical, such as airplanes, swimming pools, violin bows, engines and high-performance brakes, and military and police bulletproof vests. Nonetheless, matrices in composites can be degraded, and therefore we must avoid using materials that will deform or break under the conditions of intended use. Thank you.